All right, so this clearly says we're revolving around the x-axis, all right? Again, you may want to just make yourself a little note. The x-axis is y equals 0, all right? Which means my functions need to be in that, and that if I'm revolving around y equals 0, as long as y equals 0 is one of my functions, one of my boundaries of what it's given me, then I don't have to worry about that subtraction piece of it, right? And so if you look at this first one, this is a really basic one. One of the boundaries is y equals 0. So I really just have to worry about the function. When I'm revolving around y equals 0, that also means that my boundaries need to be in terms of x, okay? So if you're revolving around a y equals, all your functions need to be y equals, and your boundaries need to be your x's. So this is exactly how I need it to be. It is in terms of y equals, just like what I'm revolving around. I have one of my boundaries already. They've given me x equals 1, so this guy's a boundary. I can use this to find the other boundary. Just plug it in. If y is 0, then x has to be 0. All right, so those are my boundaries. My boundaries are going to be, if I plug this in, I get x equals 0. So I have my two boundaries. I have my function. I'm just going to say pi r squared here. Pi r squared. So I'm going to say pi, my boundaries from 0 to 1. My radius, I just have one of them. That's the cubed root of x, and I'm going to square it, dx. Like to integrate this guy, I would rewrite him. This is the same thing as x to the 2/3. Integrate that.
And you don't have to do two different
So here we are still in section 1, so we are still revolving around y equals 0. Both of my functions are in terms of y. Good deal. However, I do not have a boundary of y equals 0 here. So I'm going to have an outer r squared and an inner r squared, okay? I am revolving around a 0, an axis, so I don't have to do any shifting within my functions, but none of my boundaries that it gave me in this problem are what I'm revolving around. So I'm going to have two r's here, an outer and an inner, okay? And then I'm going to have to square the outer minus square the inner when I do this. I also have not been, don't have any shifting within it because what I'm revolving around is a 0. So it's not like I have to think about where the function is in relation to another line. It's still in relation to the axis, right? But I have two functions and neither of those boundaries, like on number 1, are what I'm revolving around. So I'm going to have to do the process, my boundaries of my outer r squared minus my inner r squared. I'm going to have to do that. Outer minus inner.
But I'm confused. How do you know that?
So we have our boundaries. We have our upper and lower boundary. We have our two functions. We just have to figure out which one's first and which one's second in this process. All right? Which the graph actually that I just drew for you kind of already told you that. But assuming you don't draw a graph, my lower boundary and my upper boundary here, I do have a pi, but now I'm going to have some function squared, r squared, minus another function squared, little r squared, okay? And so if I were to take anything in between -1 and 0 and plug it in, let's say -1/2, I would get -1/4 plus 7. That's going to be 6 3/4, or -1/2 plus 5. That's going to be 4.5. So this is the larger function. Even if you didn't know how to sketch it to see that that was clearly the larger function, you can plug it in. And so once you know which is the larger function, you're just going to plug that in. -x plus 7 is my first function, and then x plus 5 is my second function. That is the setup, all right? Now, remember, the number one mistake is not foiling, okay? People want to square that first guy and square the second guy. That is not how you do that. You have to foil it. It's -x plus 7 times -x plus 7, right? Or squared. That's a squared. You have to do that twice. All right? X plus 5, x plus 5. So you have to square those. Simplify it, and then do your antiderivative after you've simplified everything that you can inside of it. When you see shifting around the y-axis, keep in mind that is the same thing as x equals 0. All right? Which means that if one of the boundaries they gave me is not x equals 0, then I'm going to have an outer r squared and an inner r squared. If the y-axis is x equals 0, then all of my functions need to be in terms of x. They are not. So in this case, I have to solve for x. So here I would say x is going to be y over 2. Here, x is the square root of y, right? So I have to solve them in terms of y. This also did not give me any boundary lines, right? No boundary lines here. And so remember, I have to have boundaries in terms of y, right? And so I'm going to set these two equal to each other. I'm going to say y over 2 equals the square root of y. And I'm going to figure out where these intersect. This is just basic algebra, right? We're squaring both sides here. We get y squared over 4 equals y. I would multiply both sides by 4 personally, so I would have like y squared equals 4y. And then you're going to subtract and set it equal to 0, right? Anytime you have a quadratic, you want to put them both on the same side, set it equal to 0, solve by factoring. Take out a y, you get y minus 4. Y is going to equal either 0 or 4. Those are going to be my boundaries. So now I know what my boundaries are, 0 to 4. I have a pi. Neither one of these are what I'm revolving around, so I know I'm going to have an outer r squared, an inner r squared. All right? I should figure out which one. So from 0 to 4, I have y over 2 and square root of y. Let's say we plug in a 1, right? 1/2 compared to the square root of 1. Square root of 1 is bigger than 1/2, so this one's going to go first. Square root of y is going to go first. Y over 2 is going to go second there. Remember, you want to simplify it. So we have y minus 1/4 y squared. And then antiderivative at that point, right? I haven't actually taken my antiderivative yet. I've just simplified prior to. So you should end up with a fraction, right? So we have 1/2 y squared minus 1/12 y cubed. We get 16 over 2 minus 64 over 12. This is 8. This goes in 16/3. 16/3 is 5 1/3. So that's 2 2/3, which is 8/3. And then we have that little pi there. Now, for this one, and for everything on this page, it tells you what your axis is. It doesn't mean that your axis could potentially not be x equals 0 or y equals 0. Happens to not be on the back page. If it said it's revolve around x equals 0, that just means y-axis, right? I mean, so don't let it throw you if they list it that way. But on all of these, you're not on an actual y or x axis when you're rotating. So automatically, you know there's a shifting that's going to happen, okay? Because you're no longer taking the function all the way to the axis. You're actually only taking it to a certain point. So you're actually going to have to subtract depending on where it is, one way or the other, okay? So then you just have to say, okay, is there going to be a gap? So I know I have to shift my function. Is there going to be a gap between two functions? And so we have to look at that. I actually chose this particular one because we have to set it up one way first. I am still going to look at my axis and say, okay, my axis is in terms of y. That means all of my functions need to be in terms of y, okay? And so I am going to get all of these in terms of y. I'm going to say squared and squared, okay? So this is x squared equals 3 minus y. And this is x squared equals 3 minus y. while it looks like I have two boundaries, when I square them and put them in terms, I don't. I actually only have one boundary here. All right.
Negative 3 minus.
What happens when you square a negative?
Oh, it becomes positive.
Okay, so even if I divide by negative first and then square it, it's going to be the same thing, right? Does that make sense? And so in terms of y, this is going to be 3 minus x squared, both of them. So I have one guy here, 3 minus x squared, all right? Now here's the thing you have to keep in mind. He is being shifted, okay? We are not revolving around y equals 0. We're revolving around y equals 2, okay? And so I am going to go, so if I do this, 1, 2, here's where I'm revolving around right here. That's what I'm revolving around, okay? This function here is a shifted parabola, pretty much, right? This is a shifted parabola. Y equals 3 minus x squared. That's actually a vertex up here and a parabola up here, right? So I am just shifting this piece right there. I'm not rotating the whole parabola. I'm rotating that guy, okay? But I am rotating around this. So it's not like there's a gap. It's not like I'm doing parabola and line and rotating it around an axis where there's this huge gap. I'm taking a piece of a parabola and rotating it around a shifted axis. So within my function, I'm going to add or subtract either from the 2 or subtract the 2 from my function. And then that's going to be my one radius. I don't have 2 radii. I don't have a washer because what I'm revolving around is butted right up next to my function itself. But that function is not on the axis. So within the function, I have to subtract that 2, okay? And you're still gonna do this the same conceptually. Sometimes you'll take the line and subtract the function because the line's above it, and so you're subtracting below it. But in this case, the function is above the line, okay? I know that because first of all, when I get my boundaries, I can tell you whether it's not, but just the same way I would anything else, is 2 above or below it. I can look at this hopefully and tell. My vertex of my parabola is a 3. My line is at 2. Clearly the parabola is above the line, right? Based on that. But even if you didn't know it, you could figure it out the same way you figure out between 2 functions, okay? You could still figure that out. And so I am going to, within this function, before I square it, so I'm going to have this guy, I'm going to take the function and I'm going to subtract that line out because I'm only going from function to line, and then I'm going to rotate. Then I'm going to rotate. That's going to be my R, from function to line. I'm not taking function to line and rotating around an axis. That would be R squared minus R squared, right? I have a gap. I'm taking the piece of the function and rotating around the line that's cutting my function off. No gap. There's no hole in this one. I don't have a washer. I have a disc, okay? Because what I'm rotating around and part of my function boundaries are the same thing. They tell me to rotate around the axis y equals 2, and in my boundary lines, they give me y equals 2. So I'm going to subtract before I square here. There's no hole. If I have a hole, I'm going to square first and then subtract the 2.
So you don't have the...
If we were to set each one of these equal to 0, we would get the same thing. We're going to simplify this right here. And we're going to say that's going to be, you can either say negative x squared plus 1 or 1 minus x squared. All right? This is actually going to cross because what I did was I subtracted those 2, outer and inner, that line. Those cross at 2 different places. So if I were to set my y equals 3 minus x squared, right? And my y equals 2, which is the other boundary, equal to each other, you're going to get where that parabola crosses your line, right? So I'm going to say 3 minus x squared equals 2. Subtract 3, divide by negative 1. X squared equals 1. The square root of x squared is going to be positive and negative 1, okay? So technically I have an outer and an inner, but I am subtracting before I square because I don't have a gap in this one. If you have a gap, then you're going to take your two functions and square them individually. If you don't have a gap, you're going to put them together and square them together. And so my boundaries for this are going to go from -1 to +1. And then again, you have to FOIL this. Take your antiderivative, plug in 1 and -1. So these are my two boundaries, my two functions, right? Y equals 2 and y equals 3 minus x squared. Okay, those are my boundaries. Now I'm going to say, do I square first and subtract? Or do I subtract first and then square? That depends on what I'm revolving around. I am revolving around one of my functions that is also a boundary. There will be no hole, okay? Which means, just like when you were finding the area between the curves, subtract the two functions. That gives you what you're revolving, okay?
What do you mean square first, then subtract over and over?
So if there is a hole, say there's going to be a hole, I'm not revolving around one of my boundaries that they've given me. I'm revolving around something else, whether it's the axis or whether it's another line. Neither one is one of my boundaries that they've given me. There's a hole. Then you're going to use the outer, you're going to square those functions individually when you subtract, okay? If there is no hole, so we have no hole, which means one of my boundaries that they've given me and what I'm revolving around are the same thing, no matter what it is, whether it's an axis or another line. Then you're going to take your two functions, and you can think of it as r's, it doesn't matter. You're going to subtract them first and revolve because you're not creating a hole. Okay, so on this one, we are revolving around the axis x equals 2. Okay, first thing we need to point out, which means our functions need to be in terms of x. We actually do have two functions in terms of x, this one and this one. We don't have to rewrite anything. Our boundaries have to be in terms of y. Here we go. There's my boundaries. All right. Neither of my functions butt up to what I am revolving around. So I am going to do a squared and a squared. So I am going to do something like this. A function squared minus a function squared. Okay. So that I am going to do that. The other thing I need to keep in mind is I am not revolving around an x or y axis. So the functions themselves are being cut off. The pieces that I am rotating are being cut off by this right here, either at the top or at the bottom, okay? So here I have to figure out which is higher or lower within the r's, okay, to decide if I do what I'm rotating around minus the function or the function minus what I'm rotating around. I also have to determine which one's higher or lower within my r's that I'm squaring because I am not going all the way to an axis, okay? What I'm revolving around is one, not a boundary, and also not an axis like y or x axis, okay? So I know for a fact I'm going to do squared minus squared, okay? The other thing I have to think about is what does it actually look like? So I'm going to set up my boundaries first, 0 to 1, okay? And then I am going to shift them first. So I'm going to take the x equals -4, all right? And I am going to compare that to what I'm revolving around, all right? This is easy. Which is higher or lower?
X equals 2.
Okay, x equals 2. So this function that I'm going to square is going to be the 2 minus the -4. Okay? Because I'm not taking x equals -4 all the way to an axis. I'm cutting it off, right? I'm cutting it off. So I start at -4. I'm not going to revolve everything up to the axis. right? Or actually it goes this way because it's x equals. So x equals -4 on y'all's perspective is here, right? I'm not going to revolve everything up to the y-axis. I'm going to revolve everything up to x equals 2. Okay? Does that make sense? So I need to figure out what that looks like. That actually looks like an x equals 6. Okay? So that's going to be one of my functions that I revolve. Let's look at the other guy. For the other one, we have x equals -y squared minus 3, and x equals 2 is what we're going to compare it to, okay? Again, I need to figure out which one is higher or lower. Well, between 0 and 1, if I plug in anything, this is going to remain a 2. This guy is going to be a negative number because I'm going to have some fraction squared minus 3, right? Some positive number, any number squared is going to be positive. Then I'm going to negate it, then I'm going to subtract 3. So again, this is first. So now my second function is going to be 2 minus -y squared minus 3. This is shifted and a whole, okay? Do you understand the difference between what we did like earlier? So now this one looks like 2 plus y squared plus 3, or 5 plus y squared. That is my second function, okay? So I have a function x equals 6 and a function x equals 5 plus y squared. Now, those are the two, right, those are the two I'm going to use up here. So between 0 and 1, for these two new functions that have been shifted, I need to figure out which one comes first and which one comes second, right? 6 is always 6. That's easy. If I plug in some fraction and square it and add it to 5, it's not going to get bigger than 6. So my 6 is going to come first. And I'm going to say 6 squared minus 5 plus y squared. Squared. Okay? So had I been butted up next to that x equals 2, then I wouldn't have had a whole. I would have just shifted my function within it and squared once and been done. But I have two functions. Neither of them are what I'm revolving around. Both of them are being shifted by an axis because it's not a y equals 0 or x equals 0.
So